Assalamualaikum warahmatullahi wabarakatuh. Now let's pray together by saying Basmalah. Good morning everybody, good afternoon everybody, how are you? Today I will continue our last week discussion about how to find out the characteristic root of the equation. Last week we have already discussed three methods. So bisection, tabulation, and also regular fallacy or false regulation. And today I will give you two more methods. The first one is method iterasi xgx or iteration x equal to xgx. Okay. And then the second one will be Newton-Raphson. I will start today's discussion with iteration xgx methods. I don't want to talk any longer. I just want to give you equation and how to solve this equation. For example, I have equation y equals to x cubical minus 9x squared plus 18x minus 6. So how we solve this equation using iteration xgx methods? The first step, you should transform the equation x cubical minus 9x squared plus 18x minus 6 into the form of x equal to gx. How is it? The easiest way is move the coefficient x in right hands into left hand. For example, this one is 18x. The coefficient x is 18x. I move from right hand to left hand to left side. So it will get this equation. So minus 18x equals to x cubical minus 9x squared minus 6. That's how we transform into x equal to gx. We divide it by coefficient x itself. So it becomes something like this. X cubical minus 9x squared minus 6 divided by minus 18. So, or I can divide them one by one. So equals to x cubical per minus 18. And then minus 9x squared per minus 18. And minus 6 per minus 18. You can see? Then it is simplified to be this one. X equals to minus x cubical per 18 plus half x plus 1/3. Okay, so this one is equation of x gx. Okay, the second step is we find out the differentiation. We differentiate this equation into x. Okay, so I symbolize the differential or the derivatives of this equation to be g accent x. So we find out g accent x. It is minus 3x squared per 18 plus half x. Okay, half x root square 0. So we can find that the derivatives of the equation is minus x squared per 6 plus half. This one we use for the requirement. Okay, for the next step, for the iteration, we can use this equation for requirement. What is the requirement? The next step, we will need to find out the first x or x1. Last meeting, we decide to for the beginning of the iteration, we decide two x0 and x1. So for these methods, we only use one x, so x1. For example, for this equation, I use x1 is a half or 0.5. So we just put in the equation. We just put 0.5 into the equation of requirements. Okay, so we calculate that the result is 0.4584. So it is it meets with the requirement. What is the requirement? So the value of the accent x should be around 1 and minus 1, but should not be or must not be 0. Understand? So we can conclude that we can use 0.5 for the next iteration. And the next calculation, we use iteration. Okay, so just we make a table, something like this. We can write down x1, 2, 3, and so on. Okay, so x1 is a 0.5. So we just put down how we how we find out the x2. We just put 0.5 x1 into the equation of gx. So we will find 0.57606. How we find 0.63? We just put 0.57 into gx. We will find x3. How we find x4? We just put x into this equation. We will find x4 again and again and so on. So how will this iteration stop? The iteration will stop when there is no more change of the value. For example, until let's say 6, 7, 8, 9 iteration, you find that the x is 0.552658. So again and again until 3 or 4 times, so it indicates that the iteration stops here. And the root square is 0.55265. Understand? Okay. You can write down before I continue to the next method, Newton-Raphson. Okay.